This is an example of a t-test with sample statistics using Excel. The problem states that we have a null hypothesis with the population average equaling 82.3, and the alternative hypothesis that we wish to test is that the average population does not equal 82.3. Thus, this is a two-tailed test. In this Excel sheet, I've recorded some of the important information already from the problem that's been given. The average from the null hypothesis is 82.3. We can see that the sample mean is 86.5, the sample standard deviation is 8.5, and the sample size is 30. The problem asks for the test statistic, and then it asks us to calculate the p-value and answer some questions following the p-value. The first thing that we want to do is to calculate the mean difference, in which we take the hypothesized population mean away from the sample mean. So we would take 86.5 and subtract 82.3. Next, we need to calculate the standard error, which is done by taking the sample standard deviation and dividing by the square root of the sample size. And dividing 4.2 divided by the standard error, the difference divided by the standard error gives us our t-ratio of a little more than 2.7. Now, the problem here is that a lot of students erroneously use the normal distribution to calculate the p-value. In other words, they would do something such as 2 times 1 minus norm s dist of the value 2.7, where they're treating it as a z-score, even though technically it's a t-ratio, and they would obtain a value such as 0.006.8. Unfortunately, this is actually an underestimate for the actual p-value, the probability of observing a sample score of 86.5 if the population average is indeed 82.3. Instead of using the normal distribution, because the population standard deviation is not known, we actually need to use the t-distribution. T-distribution requires the degrees of freedom, which is 1 less than the sample size. With this, now we can use the function equals t-dist, in which we can give the t-ratio that we calculated, the degrees of freedom, and then the last argument is the number of tails in the test, which in this case is 2, and we don't actually have to do the additional calculation that we needed to do using the normal distribution, and this will give us a p-value of 0.01127 and change. And if we compare this to the answer that WALMAP is actually looking for, we do indeed see that that is the correct p-value.